Thanks for coming out. There's a ton of people in here. So I'm going to go ahead and get started. I got a lot of stuff to get through. Thanks for having me. My name is Neil Peterson. I work with Microsoft in Azure. I'm from Seattle, Washington. This is my first time in Warsaw, so this is pretty cool. Privileged to be here. This talk is titled Consuming Cloud Services with the Kubernetes Service Catalog. Like I said, I've got a bunch of stuff to go through, including a whole bunch of demos, or rather a really big end-to-end demo. And a couple things. The projector's not great, and there's going to be a lot of command line involved here. And I noticed it is kind of pixelated. It's kind of hard to read. So as I'm going through, I will do my best to describe everything that's going on. The very last slide in this deck, I have links to everything that I'm going to be doing. So all of the YAML code, while it might be pixelated here, if you want to grab it afterwards, it's all available. And then secondly, the internet is not that great. In fact, I couldn't get internet in the room, and I'm going to be hopefully going to be doing live demos against Azure. So I am tethered to my cell phone. We'll see how that works. It's been working good so far. I do have a video in the event it doesn't work out. But again, the video quality is kind of bad, and I'd rather do live demos if we can. So all of that in mind, I've got a great session planned for you, and I hope you enjoy it. So the agenda here is really, first we're going to, before talking about Kubernetes and the Service Catalog, we're going to look at kind of a modern application and really kind of lay out the problem statement of what the Kubernetes catalog is trying to solve. Then we'll talk about Kubernetes a little bit. And I'm really going to emphasize the beyond containers here, and we'll talk about what exactly I mean by that. And then we'll see how to integrate Kubernetes with a cloud provider, whether that's Azure, AWS, etc. But what we'll see is through using the catalog, it's almost like bolting an Azure data center or an AWS data center onto your Kubernetes cluster, and it's pretty dang cool, and we'll see how that works. Then we'll dig deeper into the Service Catalog and really look at okay, once we install Service Catalog on top of Kubernetes, how does it change Kubernetes? What does it add to Kubernetes? And then finally, like I said, we've got end-to-end demos. So, show of hands, is anybody currently using Kubernetes? Or just even playing with Kubernetes? Okay, awesome. And like I said, it is going to be YAML heavy, really kind of looking at Kubernetes objects in their native form, but I will also, in addition to kind of like describing what's on the screen just in case you can't see it, I will also talk conceptually about what we're doing, because this isn't just about the internals of what's going on, but there is like some cool concepts that I hope to land with this session. So that said, like I said, before we dig into the meat of Kubernetes Service Catalog, I want to look at an application and really talk about the problem statement that we're trying to solve here. So this is it's a somewhat simple application, kind of built in a microservice or distributed format, and we're going to see this application in the demo today. And this application is built of basically 6 pieces. And how I've broken this down is that these 3 pieces are these boxes here represent containers or pods inside of a Kubernetes cluster, and these 3 boxes over here are not in the Kubernetes cluster. These are cloud services. And what this application does is I've got a container or a pod that's basically watching the Twitter. Twitter has a streaming API, so you can just pull tweets off of it that match a specific word. So I've got a pod that's just watching that Twitter streaming API and pulling tweets off. So pulling the text of tweets off of that, and it stores them in a message queue. In this example, this is an Azure storage queue. So we can already see I've got part of my application is in a container, part is not. Part of it is in Kubernetes, part of it is not. I then have another set of containers that are watching this message queue, and as stuff lands on the message queue, this container or set of containers, this is kind of part of the application that you can scale out or horizontally scale to kind of increase throughput. It's pulling these tweets off of the message queue, taken the body of the tweets, and evaluating them against Azure Cognitive Services Text Sentiment Analysis API. So basically just to figure out, is this a positive tweet or a negative tweet? Was the person happy or sad when they made the tweet? This data is then stored in an Azure Cosmos database. And then finally, there's another container that's just visualizing the results. It's just a Flask website that is just a chart that's charting the results of all of this. So, relatively simple application. But one of the things I really the point I wanted to land here is that we do talk a lot about Kubernetes, we do talk a lot about containers, and we do talk a lot about Kubernetes as an orchestration method or a management method for managing our containers or our applications. But here we have a single application, and it's not all containers. But I still want to manage this as a single application. So while there's a lot of benefits in building applications in a distributed form like this, they're easier to write. We can scale individual pieces. I mean, there's just a ton of benefits. Kind of from an operational standpoint, in managing these applications, there are some challenges. So if we're looking at this application, I've got these pieces are in Kubernetes, these pieces are in Azure. So right away, I've got multiple deployment routines. When I first wrote this application, I literally started this container and then ran and started this, built this message queue and connected them together. And so I've got kind of two environments that I'm working in, and I've got multiple deployment routines to kind of manage all the different pieces. And along with that, I've got multiple different management tools. If I was manually doing this, I'm using kubectl on the Kubernetes end to do this piece, and the Azure CLI or Azure PowerShell on that end to do those pieces. So those are kind of the obvious ones, but there's some cooler ones, and we're going to see them here. And there's some cooler problems that the Service Catalog solves, and one of those is secrets management. So here I'm getting tweets, and I need to put them there. And here I need to pull them from there. Well, in order to do that, this container, or the application inside of this container, needs to have the location of that queue and the access keys to that queue. So again, going back to when I manually deployed this the first time, I needed to deploy this and find the location and the access keys, and then go set those as environment variables here. So I've got this secrets management problem, and that is basically connecting these two things together. And then what I think is even cooler, and something I'm particularly interested in, is instance management. So if I'm manually deploying this thing, and to be fair, when I built this, I manually deployed it, and I was like, well, that was no fun. So I wrote a script to do it. And really, that's no fun either. I mean, scripts are kind of one-off things, and it didn't really work out. And then back to the kind of the fourth disadvantage here, and that's instance management. If I've got one of these, okay, I might manually deploy it or write a script to do it. That's fine. But what if I have 1,000 of these? What if this is an application that I sell, and that you as a consumer can pull out your cell phone and say, hey, I want to get sentiment analysis on something my company's selling, and you spin up an instance of this and pay my organization to run it for you. And then let's say you're done with it, and you want to delete it. Well, if I've got 1,000 of these, because of the distributed nature, I've got some containers here, I've got 1,000 of these, I've got 1,000 of those, and I need to delete one instance of the application. How do I make sure that I'm deleting the right container here, and the right queue there, and the right data store there, and I'm not kind of stepping on other running instances of that application? Pardon me? There's a bunch of different ways to do it. Is anybody familiar with Helm? Okay, and from my experimentation, Helm is a good way to do this. So what we'll see, I'm kind of jumping ahead of myself, but wouldn't it be cool if I can deploy this whole application here using Helm? to a Kubernetes cluster, including these pieces over here. And then in that instance management issue, it's just a matter of deleting a single Helm installation. So kind of getting ahead of ourselves there, but that's where we're going. So this slide I just kind of went over. Again, technologically spanning applications, multiple different deployment routines, secrets management. There's got to be a better way to do this, and that's where we're going to bring in Kubernetes Service Catalog. So before jumping into Kubernetes Service Catalog, though, let's talk a little bit about Kubernetes. A lot of hands were raised in the audience, so that's really cool. And just briefly, I'm not going to dig into detail here. I want to talk about Kubernetes kind of beyond container management. Kubernetes is really awesome. It's everywhere for a good reason. Because of, within Kubernetes, we've got these extensibility methods. Anybody familiar with custom resource definitions? A couple hands. We're kind of going down the rabbit hole in Kubernetes. So we've got these things called custom resource definitions or API extensions that really allow us to write our own solutions and capabilities on top of Kubernetes. And if you look at, if you listen to any of the founders of Kubernetes, like Brennan Burns or Joe Beda, they say things like Kubernetes is not the thing; it's the thing that runs the thing. And really, they built Kubernetes with the intention of it not being just a container orchestration or management system, but an extensible API for running applications. And that's the argument that I'm going to make, and we're actually going to demonstrate that. You can really almost think of it as an operating system for your data centers. And that's really cool because potentially someday we're going to see Kubernetes as the operating system within our different cloud providers. And now, we've almost got a common operating environment everywhere, and Kubernetes has the potential to be that. So again, it's through these custom extension methods that we can build capabilities on top of Kubernetes, and that's exactly what we're going to see. Just to note, custom resource definitions are kind of the more modern way of extending Kubernetes, gaining tons of traction. They're very cool. Service Catalog is not written on custom resource definitions. It's written via an API extension. A big part of the special interest group that manages Service Catalog works at Microsoft, and they are exploring potentially migrating from API extension to custom resource definitions. So that said, really the point here is that, for the remainder of this talk, I really want to think of Kubernetes as, let's go beyond just managing my containers and pods and think of it as a operating system for my data center that can manage applications as a whole. So then how can Kubernetes integrate with our cloud providers? Oh, Java update. You always joke about that, but it's never really happened to me. So before we dig into Service Catalog and Kubernetes, I want to step back a little bit and talk about something called Open Service Broker. What the Open Service Broker is an API specification for a standard cloud provider interface. And what this means is it's just a common way. So it came out of CoreOS, I believe. And basically it's a declaration of, hey, if you want to do things like provision or delete or interface with a cloud provider, write an API that matches this specification with these 5 operations: provision, bind, unbind, deprovision, and update. And if you've written an API for your cloud provider, whether that's Azure, AWS, or even your own custom thing, if you write an API that matches the Open Service Broker specification, then we can use other tools with that API to provision, bind, unbind, deprovision, and update solutions or services within that cloud provider. So basically what it is that we're writing an API that we can then connect to with any other tool to interface with a cloud provider. So it's just like a connection piece, if you will. And I've got a diagram here in a moment that's going to kind of put all the pieces together. So Open Service Broker, just an API specification for integrating with cloud providers. Open Service Broker is an implementation, or Open Service Broker, so all the big cloud providers have an implementation of an Open Service Broker. And there's others as well. And you could build your own. Maybe you want to interface with a part of your data center using a common interface. And to do that, you would build an API for your data center that matches the specification of an Open Service Broker API. And then I just dropped some links in here to the 3 big ones. Obviously, I'm going to focus on Azure, and it's a pretty good one. So we've defined what an Open Service Broker compatible or compliant API is. We've got some links to them. So then, okay, but what about Kubernetes and Service Catalog? So what exactly is Service Catalog? Out of the box, Kubernetes is not able, it doesn't understand how to interface with an Open Service Broker compliant API. And that's what Service Catalog is. So it's basically just a package that we install in a Kubernetes cluster that enlightens Kubernetes to now understand and be able to interface with an Open Service Broker API. And when we install Service Catalog, it adds 5 new types to Kubernetes. So if you've used Kubernetes, you're most likely familiar with kind of object types within Kubernetes. Everything in Kubernetes is an object type. Pod, deployment, service, service account. And you can interface with these instances of these object types in a very similar way, like kubectl get service account, kubectl get pod, kubectl describe pod, kubectl describe service. What Service Catalog does is it adds 5 new types to your Kubernetes cluster. Cluster Service Broker, Cluster Service Class, Cluster Service Plan, Service Instance, and Service Binding. And so just like get pod, I can do kubectl get service binding. So we're basically just extending Kubernetes. So how does it all come together? So just quick little diagram, and I've got another diagram here in a little bit where we're going to actually get a little deeper into the API. But just to kind of like solidify, because I just threw out a bunch of stuff. Open Service Broker API, Service Catalog. So what's it all mean? So we've got a Kubernetes cluster. Once we install the Service Catalog, which again, that's just we're extending Kubernetes so that it knows how to talk to Open Service Broker compliant APIs, Kubernetes can now talk to my OSBA, Open Service Broker for Azure, which is then responsible for provisioning things inside of Azure. That's how it all connects. The cool thing is we can do something like that. Once Kubernetes understands how to talk to an Open Service Broker compliant API, I can start to layer those on top of it. It's not just like, it's not specific to the Azure. I mean, that's the beauty of having an Open Service Broker compliant API. Like, once I install Service Catalog, Kubernetes can now talk to all of them, even my own custom ones. To that point, honestly, Open Service Broker compliant APIs aren't just about Kubernetes, so I could do something like replace Kubernetes with Cloud Foundry or my own custom tooling. So it's really like all the magic is here. This is the piece that interfaces with my cloud provider. Sound good? All right, so now what I'm going to do is just quickly go through the 5 new types that Service Catalog adds to Kubernetes. Some of them are more interesting than others. So the 3 that are kind of least interest, I've got here on just one slide, and then we'll kind of go deeper on the 2 most important ones. So within Kubernetes, we've got something called Cluster Service Broker, and that's just an instance of one of these. So like when I install one of these, like, hey, Kubernetes, talk to the Open Service Broker for Azure, I'm basically creating an instance of that type right there. That's the least exciting one. Cluster Service Class maps to an offering type in our cloud provider. So thinking about Azure, that might be like Azure MySQL, Azure Storage, Azure Cognitive Services. So what we're going to see is like from Kubernetes, if I want to provision an Azure MySQL instance, I'm going to create, basically this is the catalog of those services that I can provision. And it's pretty cool. Like from within the Kubernetes cluster, you can browse the catalog of services that are available in the cloud provider. Cluster Service Plan is just a subset of the class. So with all cloud services, let's just take MySQL. You might have different SKUs. Like I don't know what the names are, but like enterprise, standard, free. And that's all that this type is right here. So those are the kind of the three that just kind of get populated out of the box. And then we have service instances, and the next two are the pieces that you really interact with. I do have some YAML in here. I'm just going to blaze through it, and we'll actually see it in the demo. So when I create a service instance, and again, this is the fourth type that Service Catalog adds, what I'm doing is, the service instance is my intent to provision something in that external system. And I say intent because it could fail. It usually doesn't, but that's when I create an instance of this type right here, I'm saying, hey, I want to provision something in that cloud provider. And there's some other details there, but I won't get into them. I've got the YAML here, but let's just blaze through this, and we'll actually look at it in a demo. So service instance, I want to create something. Service binding goes back to that big problem statement that I talked about, which was secrets management. So inside of my cluster, once I've created an instance of something, I now want to bind to it. And that's what a cluster service binding is. And what I mean by that is, and when we create, actually I'll just get right to the point. When I create a service binding of an instance, what happens is that Service Catalog goes out to that instance in the cloud provider, gets the secrets, or gets the credentials, or the connection strings, or whatever has been coded as the output, brings those into Kubernetes, and stores them as a Kubernetes secret. So service instance, I want to create something. Service binding, I want to go out and get the secrets and pull them back into the cluster. So those are the 5 types, but there's one last piece here, and that's, okay, once I've done all that, how do I use it? And by use it, I mean, I'm going to start containers or pods inside of my Kubernetes cluster, and I most likely want those containers and pods to connect to the things that I just created in my cloud provider. So how do I do that? And it's pretty simple. If you've created secrets in a Kubernetes cluster before and injected those secrets into your pod, that's all we're doing here. So here I've just got a deployment, and I've got some secrets or some environment variables defined, and I'm populating those environment variables with the data that's stored in the secrets that I've pulled from the cloud provider using the service binding. And we're gonna go through every step of this. All right, so just getting kind of a little deeper, really wrapping all the pieces together, and then we'll jump into some demos. So in this diagram, the dotted line here represents a Kubernetes cluster. Brand new Kubernetes cluster, Kubernetes API. We haven't even installed Service Catalog at this point. And then I've got my cloud provider over here, Azure in the case of this demo. So the first thing I'm going to do is install Service Catalog. Notice that I've got it inside of the Kubernetes cluster. There's a Helm chart for doing this. It's very simple. Install the Service Catalog, Helm chart, boom, Kubernetes now knows how to talk to an Open Service Broker compliant API. Then I most likely want to install an Open Service Broker compliant API. In the case of OSBA, or the Open Service Broker for Azure, again, we've got a Helm chart that'll do that. I believe it's Google. I believe their Service Catalog, they actually have it as a service, as an exposed endpoint, so that you don't actually even have to install it on your cluster. I don't know for sure, but I believe that's what I read. But in the case of Azure, you can just install this as a Helm chart inside of your Kubernetes cluster. So now you're running the Open Service Broker API as a pod with a replica set inside of your cluster to keep it nice and healthy. And I kind of missed this, but once we install the Service Catalog, we've got these 5 new types. Once we install Open Service Broker, we've got a list of services that we can create in the cloud provider. We then create a service instance, which then actually deploys inside of our cloud provider whatever it is we want to deploy, database, storage, analytics, or cognitive services service. We then create a binding, which pulls the information from that cloud provider and stores it in a Kubernetes secret. We then start our application as a pod inside of our Kubernetes cluster, which grabs those connection strings and access keys, and then can start to utilize the service that we've deployed in the cluster. Just a quick note, so there's this command line tool called SVCAT. This really confused me when I was learning about Service Catalog. I was like, do I need this tool, or like, why do I need another tool? This kind of like, this takes away some of the value proposition. I want to just be able to deploy that first application with those 3 pods and those 3 cloud services. I just want to use a Kubernetes manifest. I just want to use YAML. What is this command line tool? And it didn't take long before I figured out what it is. When you're like browsing the catalog and you're seeing the instances that you've created and you're seeing the bindings that you've created, you can use kubectl to do it, but it's a little clunky. And I'll show you the clunkiness to it. SVCAT is just a convenience tool for kind of manually like ad hoc browsing this stuff and working with this stuff just one-off, but it's not necessary. I do call that out because I'm going to use it a little bit, and it did kind of confuse me when I was first learning about this. And then finally back to our application, and I kind of like already let the cat out of the bag, but you know, wouldn't it be cool if I can write a Kubernetes manifest file or a Helm chart that deploys not just the Kubernetes pieces, but like the whole application? And then going to that instance management stuff, you know, if I had 1,000 of these, wouldn't it be cool if I could just do something like Helm delete and then select one instance? And not only would it delete all of this stuff, but go out to my cloud provider and delete all of this stuff. And that's exactly what we're going to do. That said, there's always a catch, right? And these are just some notes based on my observation. Building this application, deploying it through this, bunch of other things that I've done with it. I mean, it's early days for a lot of this stuff. There's definitely some rough edges around some of the stuff we're going to see. There's no current support for RBAC, role-based access control, although there is a proposed spec to get that in place. And this came up, I did this talk a while back, and somebody said, well, hey, I could do all of that with Terraform. Absolutely. You could do all of this with Terraform. There's potential alternatives to a service catalog, so just be aware of that. And then potential delay in cloud service parity. This is kind of one that I'm a little passionate about. An example of this is right now the Open Service Broker for Azure, it only supports like 12 Azure services. So it's not like, it doesn't inherit all the capabilities of Azure. And this is the same for all the service brokers. So we build new capability into Azure. Somebody needs to go build that into the Open Service Broker for Azure. In this particular application, this piece didn't exist when I first wanted to do this, so I had to go out and code a module for text analytics and get it merged into the product. Fortunately, it's an open source project, and it was relatively simple to do. And I mean, it was almost like, I'm not a great developer. It was almost like just taking boilerplate code from some of the existing modules and switching a couple things out. So it wasn't that difficult. And then finally, you know, one thing I'll say, I took it off the slide, but I had it as a bullet point before, is that it's kind of funny when we start working with Kubernetes, we're used to like, you know, kubectl run or whatever, or like start my application. It's like, boom, the application starts. Well, an Azure Cosmos database doesn't just start. It takes, you know, a minute or two to get that thing fired up. So when we start doing this integration with Service Catalog, you know, the deployment time of our applications doesn't necessarily match to the deployment time of the container pieces. We've got the cloud services in play as well. All right, so there's a slide if you want to grab a picture, or I'm sure they're available, or reach out to me on Twitter. Twitter, it's at @NEPeters. I'd be happy to share this with you. Basically, everything you're going to see, we've got documented. We've got the samples ready to go. And that said, the rest of this is all demo. I'll see how we're doing. So how am I doing on time? We have about 25 minutes left, I think. What time does this session end at? I have how many? 14? Okay, so we'll go really quick. First thing I'm going to do here is, and again, we'll see how this works. I'm tethered via my cell phone. We can see here I've got an Azure. I've got my Azure instance here. I've got a couple resource groups. First thing I'm going to do is actually deploy that application. And like I said, I'll describe what I'm doing. I know that's hard to see. I'm going to deploy the big application because it does take a couple minutes to deploy. I'm going to get that running, and then we're going to step back and look at something a little more simple and just kind of look at the nuts and bolts of the pieces. But so I've got Helm install Azure samples, Twitter sentiment, dash F values. I've got a values file here that just, I'm passing some values to Helm. It's my connection keys to the Twitter streaming API. And then I've got set filter text cake, like the cake that you eat. So what we're going to do is we're going to pull tweets off of the Twitter streaming API that have the word cake in it. I picked that because I love cake. And I'm assuming, we're going to get mostly positive results out of that. So I'm going to go ahead and so all I'm doing is installing a Helm chart. The Helm chart is at Azure Samples, Twitter Sentiment. You can go look at it. It's pretty cool. I mean, you've got deployments, you've got pods, but you've got service instances and service bindings. And you've got these new types that we've talked about. So not only have I installed Service Catalog on my Kubernetes cluster, but I now have these new types that I can work with natively in Helm. And you can see a bunch of stuff was deployed. So I've got typical stuff, deployments, services, secrets, but I also have service bindings and service instances. So let's pop over to Azure and see what's happening. And this is the part I'm a little nervous about because of the cell phone connection, so see what we got. And there we go. So we can actually see a resource group is created. And if I dig into that resource group, we can actually see that I've got 3 services created. And if you go back to that chart, remember it was 3 containers, 3 services. So there's my 3 services. And if you stop and think about what just happened there, that's actually wicked cool. We just did what I said we would do, which was we deployed Azure services with Helm. Now, they're still in a deploying state. So let's just look at a couple things while that deploys. I'm just going to run kubectl get pods, all namespaces. Let's look at a little bit of the infrastructure. So as I talked about, we can install Service Catalog using a Helm chart right inside of the Kubernetes cluster. We can install the Open Service Broker for Azure right inside of the Kubernetes cluster as well. And this is where it's going to make a fool of my phone. There we go. So if we look at the pods inside of my cluster, you can see I've got 2 here that are in a namespace called catalog. So this is the service catalog. So it's running inside of my cluster as a deployment, as pods with a replication controller. In fact, you can see this one's crashed a couple times because I've been thrashing it around. Replication controller brings it back up. No worries. Secondly, down here we've got the Open Service Broker. So it's running inside of my cluster as well. It's got a Redis instance and then the actual controller. So I just wanted to make a point that in fact the components that make this up are actually running right inside of my cluster. I can run kubectl get API service. And we can go in and we can see in here I've got Service Catalog. So I talked about the 2 different ways of extending. There's actually a couple more different ways of extending Kubernetes. One is API, extended API, and the other one is custom resource definitions. So when you install, and this just says v1 beta, servicecatalog.k8s.io. So when we installed that service catalog, it basically aggregated APIs it's a chunk of API that just sits on top of the Kubernetes API, and it almost looks like we've actually extended the API, but it's separated. So I talked about the 5 objects that are created. The first one being ClusterServiceBroker, which is just an instance of an Open Service Broker installed in my Kubernetes cluster. So I'm running kubectl get ClusterServiceBroker, and it's going to return back OSBA, Open Service Broker for Azure. Again, I could have AWS installed on here, and so I'd have 2 of those. There's not a lot to do here. I'm just kind of like showing the infrastructural aspects of this. And if I do like kubectl describe cluster service broker OSBA, we can get information about that cluster service broker, or about OSBA. For instance, right here, somewhere we should see a message, successfully fetched catalog entries from broker. You know, one thing I didn't really call out in the slides, and I'll pull this up, is we've installed Service Catalog in Kubernetes and Open Service Broker, but like, how are we authenticating against Azure to actually create these things? Because there is a, you know, we do need to authenticate against our cloud provider to put this stuff in. And what it is, and in fact, you can see some of it right here, so I'll delete this later. But when I installed Open Service Broker for Azure, we give it credentials. In Azure, these credentials are in the form of what's called a service principal. And so we give the Open Service Broker for Azure an identity inside of the Kubernetes cluster. So just wanted to point that out. So let's do this. I talked about kind of the native experience using kubectl being kind of clunky. Let's take a look at the second type that's added to Kubernetes, which was the cluster service classes, which is kind of that catalog of services that I can work with inside of Azure. So I'm going to run kubectl get cluster service classes. And what you'll see is it returns back just a bunch of GUIDs. Like this is where some of this clunkiness is coming in. Like that's not helpful. Like one of these is mine, and it maps to Cognitive Services Text Analytics API, but I can't tell which one it is. Now you can actually run kubectl get cluster service classes with a kind of a custom table or add some custom columns, but you can see that that's like a pretty big long line there, and I'll never remember that. But if I run this command, and it doesn't matter what the command is because we'll never run it because it's too long to remember, but we can now see the mapping of these unique IDs to the services. And this is actually pretty cool. Like from my Kubernetes cluster, I can now see a list of services that are available for me to provision in Azure from that cluster. So we can see Azure MySQL, Azure Text Analytics, that's the one I put together, Cosmos DB, Event Hub, Service Bus, some more MySQL. So cluster service classes is that catalog. However, we can do better, which is where that SVCAT tool comes into play. So instead of this kubectl stuff, like if I actually want to browse this thing, I'm going to use SVCAT get classes. And it's a much more manageable list of things that I can read that make sense to me. So again, simple command. I don't need to, add additional columns. I can see a list of the services that are available. As well, I can run SVCAT get plans. And actually, I'm going to run SVCAT get plans, and I'm going to grep for Azure Storage. I should have 2 or 3. Yeah, there's 3. So I've got 3 classes, so I've got Azure Storage as my class. Then I've got 3 different plans, and it's kind of line wrapping here, but like general purpose. Blob container, blob storage account. So basically 3 different offerings of storage. Along with that, and I'm going to skip a couple things here. In fact, I'm just going to go off the ranch and just totally ad-lib the rest of this. Let's see how my deployment's doing. So I can actually use SVCAT to do that. So I'll do SVCAT get bindings. Let's just do get instances. All right, and so I've got ready, provisioning, and ready, and it's that Cosmos DB one that's still provisioning. It does take a little while to provision. So I used SVCAT to do that, but just to prove that we can do it elsewise, and also take a look at this YAML file here. So I've got a YAML file, kind service instance, just some metadata, and then my spec, so cluster service class. So remember the service class is the service that I want to provision, Azure Storage, cluster service plan. So remember the plan is the SKU of that class. I've got blob container, parameters, location, East US, and then resource group, OSBA storage demo. I had actually deployed the Twitter example, but I'm not going to deploy this just for the sake of time. But if I did, we would create this resource group in this region and provision a piece of storage. But what I wanted to show is I can do kubectl get service instance and also see the service instances in my environment. And I could do kubectl describe service instance. And let me just get this Cosmos DB one because it's the one that is still provisioning. And if it's not obvious, I mean, this is the exact same thing as using that SVCAT tool. It's just, you can see here, it's more clunky using the native Kubernetes tools. But SVCAT is not necessary. Like, once you have your manifest files ready to go, once you have your Helm chart ready to go, I mean, you're just deploying this stuff and deleting it. And we can see here the instance was provisioned successfully. All right, so let's look at binding. Kind, service binding. Basically, I give it an instance name, just basically like, hey, this is the instance that I want to bind to, and then I give it a secret name. That's the secret that I want to create when I bind to that instance. And again, binding to the instance means pulling the connection strings, any kind of keys I need to connect to that instance into my Kubernetes cluster, into the secrets. So let's see how my bindings are doing. And again, I could use kubectl to do this, but that's clunky, so I'm going to use SVCAT. Get bindings. All right. And hopefully they're done. All right, so notice this one says error, instance not ready. This is some of those kind of rough edges. It's not an error. It's just waiting for that instance to complete before it can bind to it. And there is like a little bit of a delay. Like if I do SVCAT get instances, it's going to say done. It just, I'm assuming it's on some kind of control loop, and it just hasn't looped yet to recognize that the instance has been completed so that it can bind to it. And then finally, while that runs, we'll just kind of look at one of the applications. And again, it's just as simple as once we create that binding, we're going to create a secret inside of the cluster. Inside of my pods, I'm just defining an environment variable. And then I'm going to give that environment variable the value that's inside of that secret. So like when I wrote that application, each one of those pods is expecting an environment variable of a certain name so that it can then go and connect to that service. And hopefully this is done. And really it's the bindings piece that I want to take a look at. All right, so they're all ready. Check this out. I'm running kubectl get secret. Kubectl get secret, and a secret was created. Actually, 3 secrets were created, one for each one of those services that we bound to. And I can actually inspect those secrets and then map the values inside of the secrets back to the services inside of Kubernetes. Usually I'll do that, but we don't have much time here. But we can see here's the 3 secrets. And notice that everything we've looked at has a common name, Killjoy Hummingbird. That's the Helm name that has been given to this. So everything, every instance of anything that's tied to this application has a common name that came from Helm. Going back to that instance management stuff, if I do Helm list, I'm going to have a Helm release that's called Killjoy Hummingbird. And so I can kind of map everything together. And then there it is right there, Killjoy Hummingbird. And then so if I was to do Helm delete Killjoy Hummingbird, it's going to delete all the pods and all the services inside of Azure. And then finally, I'll do kubectl get service. If you haven't used Kubernetes, what a Kubernetes service is just an endpoint in front of my application. In this case, I created an endpoint of type load balancer. So a public IP address was created on top of my Azure load balancer that will plumb me through to my application. So I'll go ahead and get that. And hopefully, if everything worked, we'll see the chart that has the results of the sentiment of tweets that we've collected in the last couple of minutes that have the word cake in them, which you can see there. That's my talk. I don't know if I have any time for questions right here, but I think lunch is next. So unless anybody throws me off the stage, I'll be happy to answer questions. Awesome. Well, thanks for coming out.